So in the last video, we set up this sort of environment where we are pretty much just drawing a color to a window. But we ran through a lot of this stuff without what we could have explained a little bit more. So in this video, I'm going to talk about 4 really important structs, and those are the window, the surface, the rectangle, and the event. These 4 structs are super important. They're going to come back a lot, and actually if you understand these 4 structures, that's almost all you need to make games with SDL. So the SDL library is really well documented. We can simply control-click on each of these and we'll go to their definition. So here we're looking at the window, and up above we have a documentation of the struct with all of the functions that we can call on it. So the purpose of a window really is to hold everything together and to get events, really, is what we can do with it. We can scroll through here and see all of the options that we can set, and see we use this OR symbol to chain options together. This is a bitwise OR. These values here are called bit fields, and the reason for that is if you look at the corresponding bit which is set in each of these, they're actually independent of each other, and that means when we OR them together or just literally add the numbers together, that will be setting individual bits, which is, yeah, very cool. I guess the other thing I was going to look at, like if in doubt, we can always just browse through here. Honestly, I find this better than the official SDL documentation since, as we saw before, it doesn't even load properly sometimes. Let's go, so we can browse through all of this, but I wanted to look at the function to create the window. Here we go. So again, if in doubt, read through the documentation, and it lists explicitly the various options that we can chain together when we create the window. Yeah, so that is the window struct. It's very important. And just as important is the surface struct. So remember, we created a window. Actually, let me go back to there. So create window, and we can see here that it returns a pointer to an SDL window. We can see the arguments that it takes as well. So, okay, all well and good. So we have the window, and then what we did is we got a surface of that window. So a surface is pretty much an array of pixels, an array of numbers, and when we write to the numbers, they get drawn out to the screen. So we can click into the surface struct, and we have a bunch of flags, I guess the various options of the surface, the pixel format, which again, nothing mysterious, click in there, and we see must be various combinations of these provide the various RGB combinations that we could have. Okay, so we have flags, pixel format, we have the width and height. Again, imagine this like a two-dimensional set of numbers, and then we have the pitch. Now the pitch, think about this. We want to be able to get a random address and know where that is in the array, in the memory chunk down here. We know how many pixels across and how many pixels tall, but we also need to know how many bytes represent each pixel, and that's what the pitch is. So for instance, if we had just RGB, that would be 8 bits each, that would be a pitch of 3. But if we had RGBA, again, a byte each, that would be a pitch of 4, for instance, and that helps with addressing random pixels, as well as some other options are in here. But otherwise, this struct simply deals with, this header has functions for changing pixel formats and things. So again, we have a window. A window handles events primarily, and the display, so making it full screen and things like that. Then we grab a surface from the window, and that has a bare array to the pixels, which we can set with drawing functions. And then we grab a rectangle, which in this case I was just representing the geometric area of the window. If we click into the SDL rect function, we see that we have, pretty much what you'd expect, right? We have these 4 fields within the struct, X, Y for the top left position, and width and height. So what I've done back here is I set each of those in order. So 0, 0, top left of the screen, and width of 800, height of 600. So we're creating that struct there. If you see here, this is an SDL rect and the fields are integers. Down below we have an SDLF rect and the fields are floats. So it's fair to assume that this is a floating rectangle. And up above it's similar, right? We have an SDL point with integer coordinates and a float point with floating point coordinates. As well as if we scroll down here, we have all of these functions are already clearly defined for us. So we can use these if we want to check various collision tests. So again, this SDL rect header is actually really nice, really nicely documented, and it's not too big. So if you want to have some practice in reading documentation, that's a great header to look at. Finally, we have this SDL event. So remember, we have our game loop, and then we keep calling poll event and handle the event. But anyway, at least this removes it from the event queue so events don't stack up. So we can control click into here, and these are sort of the types that we have. Let me just search. We'll go SDL quit was the event that we looked for. Not quit event, but just quit. Actually, let me just go down. Here we go. SDL quit. Oh yeah, that's defined there. As well as the key down event and all of these. So this is defined within the event type enumerator. So again, if we're not quite sure which types of events we have open to us, we could read the documentation, we could look at tutorials, we could also just click in and have a look at the event types. Now, the other thing I wanted to look at is if we go to SDL poll event. So we were using this poll event function before. This comment gives us pretty good advice on how to handle it. It says here, there we go. So if we look down at the bottom, it says this returns an integer, and it says up the top that the 1 returned refers to this event. Okay, and if there's an event on the queue, it returns 1. Otherwise, I guess it returns 0. So it's reasonable to assume that it populates this event pointer with the current event, which has just been removed from the queue, and would return 1 because 1 event has been polled. And then we can repeatedly call this until it returns 0, in which case all the events have been polled. And it even says up here, the common practice is to fully process the event queue once every frame, usually as a first step before updating the game's state. It's very, very useful documentation, and that's one of the reasons I like SDL. It connects. All the concepts really connect. So what we looked at in this video is we just looked at 4 really common structures which SDL uses under the hood. Again, we have window, which is good for changing the display, whether it's full screen or not, as well as handling events. We have the screen or the surface, which is just a set of pixels. When you load images, for instance, when you load images, they come in as surfaces. We have the rectangle. Think of that like geometric tests and things. So it has a position, it has a size. We can do collision checks on it. When we blit to surfaces, so let me just click in here to surface, and we'll go. So when we call SDL blit, we'll blit from a source surface to a destination surface, but we need to also provide rectangles to describe the area within the source that we're copying and the area within the destination that we're copying to. So that will come up in future sessions. But yeah, so hopefully you're getting a little more comfortable with the library. Once you're over that learning curve, it will get easier. And yeah, it's fun. This stuff is fun. So yeah, that was it. I'll see you in the next one. Bye.